Today, we're diving into a really fundamental shift in how our most powerful computers actually think. We're talking about moving past a limitation that's decades old and into a totally new era of processing. Let's jump right in.
It all kicks off with this one simple question. As our digital world gets more complex, more demanding, and just faster, what happens when the very foundation of our operating systems, this idea of a single central brain, just can't keep up anymore?
To really get where we're going, we first have to understand where we've been. You see, for decades, computing has been dominated by a single design principle. And right now, that design is hitting a hard wall.
So, picture the classic operating system's kernel as this brilliant but totally overwhelmed general manager. It's responsible for absolutely everything: networking, graphics, storage, real-time tasks. You name it, the kernel does it. And for a long time, this jack-of-all-trades approach worked just fine. But here's the catch. This reveals the single kernel's biggest weakness, something called context switching. Think about our manager again. Because they can only do one thing at a time, they're constantly having to stop what they're doing, put away all their tools, grab a totally new set, and then start the next job. And every single one of those switches, no matter how quick, creates a delay. It's a tiny pause, sure, but those pauses add up and become this massive performance killer.
So here's the bottom line. When you're running simple stuff, those little delays, not a big deal. But in high-performance environments, where you've got intense networking, heavy computation, and real-time data all colliding at once, that single overworked manager becomes a major bottleneck. The whole system is basically stuck in line, waiting for one brain to catch up.
But what if we could just get rid of that line completely? Well, this brings us to a radical new solution that completely rethinks the problem from the ground up. Okay, so instead of that one overworked general manager, imagine you have this elite, perfectly coordinated team of specialists. One is a master of networking, another's an expert in real-time precision, and a third is an absolute powerhouse for heavy data. Cross-kernel processing lets this entire team work at the exact same time on the very same hardware, each one crushing what they do best without getting in anyone else's way.
And when you put them side by side, the difference is it's night and day. The old way, it's all about delays, tasks getting stuck in line, basically system-wide traffic jams. But the new way, you've got specialists working together in parallel. Tasks are truly isolated so they can't mess with each other, which means you get way higher throughput and latency you can actually predict. It's a total game changer.
So, a team of specialists sounds fantastic, right? But how does this all actually work without just creating a different kind of mess? Let's pop the hood and take a look.
So, meet the team. First up, you have the I/O kernel. Think of this one as your communications guru, flawlessly handling all the data coming in and going out. Then there's the real-time kernel. This is the precision expert, the one who's totally obsessed with timing, making sure critical tasks happen with absolute predictable timing. And finally, you've got the storage and compute kernel. This is the heavy lifter, the one that crunches the big numbers and manages massive amounts of data.
The magic that lets this team work in perfect harmony is something called zero-delay execution routing. Honestly, this is the secret sauce. It's a system that intelligently and instantly shoots each task over to the correct specialist kernel without any pause, no overhead, nothing.
And the result of that? A flow of work that is never, ever interrupted. Tasks don't have to be stopped and restarted, and they're not forced into that frustrating single-file line. Instead, you get this continuous, parallel river of execution, a system that finally unlocks the full power that modern hardware was always built for.
Okay, so we've got this incredible new architecture. It's powerful, it's efficient, but who actually needs this? I mean, where does this technology go from being a cool idea to something that's absolutely essential?
Yeah, let's be super clear here. This isn't for your everyday laptop or your phone. This is built for the most demanding, high-stakes environments on the planet. Places where you have intense, conflicting tasks that all have to run perfectly at the same time without a single hiccup.
We're talking about industries where even a millisecond can make or break you. In high-frequency trading, a tiny bit of lag could literally cost millions. For AI, you might need to analyze a data stream in real time while also running a crazy complex algorithm. In aerospace and defense, you need absolute, deterministic control and rock-solid reliability. In all of these situations, that old single-kernel bottleneck isn't just an inconvenience, it's a critical point of failure.
And this brings us to our final and maybe the most important point of all. This isn't just another little upgrade or a performance tweak. This represents a fundamental shift.
the next logical step in the evolution of computing itself.
Look, our hardware, our CPUs, they become insanely parallel. They're built with tons of specialized cores. The problem is, our software, our way of thinking, has been stuck in the past. Trying to run modern parallel hardware with an old single-kernel OS, well, it's like trying to conduct a massive symphony orchestra with just one conductor who can only listen to one instrument at a time. It's completely obsolete.
And this quote from the source material just nails it. We're not just sanding down the rough edges of an old design. We are building a completely new foundation, a structure designed from the ground up for the parallel world we're already living in.
So, as we wrap this up, it leaves you with a really fascinating thought, doesn't it? This whole shift from a single, centralized brain to a cooperative team of specialists is such a powerful idea. It really makes you wonder what other systems out there, in our organizations or our infrastructure, are still stuck with that single-minded bottleneck, just waiting for their own parallel revolution.